So you might be asking yourselves, I have all these photos now. What do we need to do to actually turn them into something worthy of sharing or turning into a print? Here are the images we shot the other night of M31. We ended up shooting 34 images, and these were 3-minute photographs. So, software I have open here, some of you might have already known this software, PixInsight. And what we need to do is we need to take these 34 images, we need to stack them, combine them, and edit them. We'll wrap up a little bit of editing in Photoshop to clean up the image for sharing. Alright, for this example, I know I'm going to get yelled at, but I did not shoot any calibration frames. In astrophotography, calibration frames include flats that remove vignetting. That includes darks. Darks will help remove some of the dead pixels and the noise in the image. And then I did not shoot bias frames. So for this example, please bear with me, didn't shoot any of those calibration frames. So the first step that I need to do, I just need to stack these images. And first way of doing that is running a star alignment on those 34 images. Alright, open up your first photo as a reference. Add files, we'll add the remaining 34 images. In total, you want to include that first image as well. And we'll set that output to that same folder that we just opened up. And we will click Run. Computer will take its time, star aligning those photographs, and then we will combine them into one image. Excellent, star alignment has just finished up, so we have 34 star aligned images. Now we can run the next step, which is image integration, to combine those 34 images all into one main image. Select all of them, click open. We're going to run the image integration combination method of average. It'll give us a nice clean signal noise ratio. Pixel rejection, if possible, you can run a sigma clipping if you might have, say, a satellite pass through one of those subframes. Sigma clipping usually does a good job at helping remove those sort of anomalies from single photos that end up being in the full final image. Image integration has just finished up, so we can close these couple boxes, and our combined photograph right here. So because some of the camera moved a little bit due to an adapter that I had that was loose, some of the frames had an overlap between them. So what I want to do next is I want to crop the images and get rid of that using the dynamic crop tool. And I'm going to draw my crop box, something to the effect of that, and click OK. Alrighty, so we opened up dynamic background extraction to remove some of this vignetting, and I started applying some points here. I had to increase the tolerance because I want to try to get to these darker edges, and I reduced the sample weight. So a lot of times you want to make sure that you do not include the target itself with these dots. These are the selection points that are going to be calculated into a model of the background. So I like to remove some of the ones that are closer towards the target, just so they don't give any ill effect points to the model. And then we will remove this background model to eliminate as much of this vignetting and light pollution as possible. Alright, so I removed the main ones that were close towards the galaxy core itself. We're going to select subtraction from the image correction, and we will click apply. You can look and stretch the background model here. You can see this is what will be subtracted from that image of the galaxy itself. This is the vignetting from the telescope and the camera. And it should be slightly improved here to an image that we can actually work with. And yes, you can see that the dark edges have been removed. Okay, after we apply dynamic background extraction, next up we need to correct for some of the color inconsistencies in this image. First up, we're going to select a preview of the background to use as a reference by clicking Alt-N if you're using Windows, and draw a little preview on a blank background of sky. We're going to go up to background neutralization, and we're going to select that reference preview image that we just created. Default settings usually are pretty good. And what I like to do, drag, apply, and it should give you a minor amount of color correction to the background. Sometimes it's hard to tell. You can blink on and off to try to see if the correction has succeeded. Like I said, sometimes it's difficult to see, but the next step that we're going to do is we're going to do a color correction via color calibration. And that usually creates a more noticeable fix, and we need to select a little bit of the white in the galaxy here with another preview. And we're going to select that target preview for your white reference. Background reference, you can use the same one that you used in the previous step, and drag and apply away. Alright, so we have color calibrated this image, and we can turn on and off our little screen stretch here. So from here, with this galaxy shot, we're ready to continue to do a stretch on the image. This is just a screen stretch that is not permanent. Alright, we can close up those tools, and we can reset our calibration here. Remove those previews that we used. And you can zoom in, you can obviously see the nice tight core there on Andromeda. Just cool. Very, very cool. What I want to do is I want to apply an Arcsin stretch to this image to bring up some of the detail, and you can turn on the preview in real time, and you can start stretching it and apply an estimated black point and kind of stretch away to bring out some of the faint detail in the galaxy. Alright, what I really like about Arcsin Stretch is it preserves that color in the stars. So I'm going to turn that preview off, close it, and I want to apply that to the image. Boom. You can see on large scale we have a beautiful retained core of the galaxy, dust lanes, beautiful dust lanes in the galaxy, the ellipticals and irregular galaxies that are neighboring Andromeda. So cool. You can see you're going to start pulling in some of that background noise. This is the color speckling that you're seeing in the background as you stretch that background where there is less signal from the exposures. So you can proceed to do a second stretch if you would like. Just be very careful because of course now it is going to be a minor amount to adjust, and you're really going to start seeing some noise come into play here even with a small stretch again to the image. Just something to boost it. Alright, so we can see before and after that last stretch. And we might even go back because we're going to start to really push the noise boundaries a little bit more than I would like, but at the same time is we start to really reveal the outer arms of the galaxy. But that first stretch did a great job. So here's what you went with. Started out with an unstretched image, just core of the galaxy. We did one Arcsin stretch, boom. We did a second Arcsin stretch just to boost it up a little bit. Now, I want to remove some of this color noise that we're starting to introduce. So the next step that we can do is we can run a TGV denoise, and that will help apply a noise reduction and remove some of the noise to the image. And a few iterations of this noise reduction technique might be just what the doctor ordered for this image. But that color noise is definitely very apparent because it was a one-shot color, a DSLR that was uncooled. Alright, so I'm pretty happy with 2 iterations of it. Next up, I notice that there can be a green cast to images. So one quick way to remove green casts of images is running the SCNR tool right here, and you can just quickly drag and drop and it will remove some of the green pixels to try to correct for that imbalanced color. So you can do before and after. It's subtle, but there is a slight green cast that has been removed, especially probably from some of these galactic arms on the outside. You can see now they're kind of back restored to that bluish color. So one iteration of that looks pretty darn good. So from here, what I'm going to do is I'm going to save this and I'm going to finish off the image in Photoshop. I'm going to do a little bit of denoising again in Photoshop to wrap this up, and then we have a final image that's pretty cool to shoot and share online. Alrighty, cool. So we have the image here opened up in Photoshop. Such a beautiful shot that I dig, especially due to the fact that this was all unguided with the Takahashi EM200 mount. Such a cool little mount. We did no HDR blending to recover the core, just because that Arcsin stretch does a great job at retaining the dynamic range. But I noticed I want to remove some of this color speckling. So I'm going to hit Ctrl J to duplicate the layer, and I'm going to go to Filter, Camera Raw. Camera Raw is a great color noise denoise tool. And I'm going to zoom in on the background, and I'm going to go down to detail, and you can increase this noise reduction tool and also this color noise tool. But of course, if you just watch that color noise goes away, of course all the way up, you can really see it kind of fade away. But I want to do something around this. Right around there looks fine. You can also apply noise reduction if you want, but right now I'm not going to do that. I want to just kind of hit up the background noise a little bit and just clean it up a hair. Alright, so that looks cool. I'm going to click OK. And we're going to see that this noise in the background has been reduced significantly. Cleaned it up as well. Some of the edges of the stars there, they had some color fringing. Alright, so this looks pretty darn good. Possibly want to just increase the brightness via levels adjustment, which I have a TK Action panel. It does a great job for luminosity masking. It's a plugin you can buy online. I found it very useful for some night shooting editing, but also for daytime landscape editing. So I might want to just grab a lights one and do a levels adjustment or a curves adjustment. Either or can kind of give you a little bit of flexibility to increase the brightness in the objects here and retain a little bit of contrast by making an S-curve. Something like that looks pretty cool, and I'm going to make sure I'm watching this top so I'm not clipping any data that comes on the top. So you do before and after. You just brighten it up, add a little bit of contrast. What might be nice, I can flatten out that curve a little bit to keep the core relatively natural looking, which looks pretty cool. Now I want to add some color back in this image here, and I just selected the lights, and I want to do a vibrance, which gives me the tool to boost up the color if I wanted to, just of certain areas of the lights. So as you can see, now we're starting to push these colors back into the galaxy, which looks pretty wild. Just beautiful. Now, since this was just on the lights, this is selecting none of the background, so we're not going to be introducing color noise back in the background with this mask. We're only adding saturation and vibrance back into the luminosity, the lights that we selected for that channel. So a little before and after, you can see added some color back into the galactic core. I think that looks pretty spectacular. And from here, you can flatten the layers and save it for the web and share it, because I think this looks pretty cool.